Okay, welcome to the Information Systems, one of your semester 1 subject in your BIT degree program. In this session, we are going to discuss the topic 1 of the subject. So before move on to anything, a small notice, since I am recording this in my home environment, the audio quality may not be optimum, so just you have to bear with me. Right, so this is one of the core subject, or in your terms, it's one of the GPA subject, and also it offers 4 credits for your degree in year 1 of the degree. Usually this subject is student find it fairly simple or easy, one of the easier subject because it's more into theory. So you have to consider two things for that. First thing is, because this is the easiest subject, make sure that you get the best out of this. Go for A plus. So it's a golden opportunity for you to go for A and A plus here. And also make sure that you understand concepts well. Why? Some latter subjects like SAD, software engineering, so those subjects are based on this particular subject, right? So therefore make sure that you have all those objectives achieved and have a very good understanding, have very good confidence, so that you face the exam well and you face the subsequent subjects in the latter semesters well. Okay, right. So let's look at the objectives first. So it's very important to have the big picture, then only you will find see the interconnections with those subtopics, so that you don't have to memorize each and every part. Right, so the first objective is understand what is mean by information system. Right, then little bit bigger context, that is understand what is mean by information system infrastructure. So we will be discussing those in the first topic. Then why information systems are important, or benefits of information systems to organization. Then different type of information systems, how information systems are acquired to organizations, so how organizations get information systems. Then some other topics like how information systems are going to help strategic management, decision making, how they are going to solve some typical business problems, right? So those things will be also covered in different sections. Then in the latter part, or the final part of the syllabus, we will be covering two topics. That is, one thing, we will be discussing some challenges when it comes to using information systems, like security issues, possible threats, etc. And also we will be covering how information systems are going to be used in ethical manner, right? So things like safety, privacy, sustainability, so those things will be discussed there. I hope you got the big picture. Let's move on to the topic 1, that is introduction to information system concepts and technologies. Here we are going to first familiar with some terminology and some basic concepts only. The first concept is basically what is data. So data is any attribute or properties of entities. So entity means basically anything that you are interested. So you can look at entities as 3 categories: living things, non-living physical things, and conceptual things. For example, if you take student, employee, or maybe customer, living entities. A machine, vehicle, non-living physical entities. The third category is also important: account, maybe order, payment, course, reservation. So those are concepts, but those are also entities that information systems are heavily working with those conceptual entities. Okay, right. So then life cycle of data. So data will be created, it will be used or managed, and when we are done with the data, we will be getting out of or get rid of the obsolete data, right? So that is straightforward. Right, so now let's move on to information. So this is the most important concept for us. So your degree is information, Bachelor of Information Technology. So this subject is information system. You can see everywhere the information is there. So information means processed data. So that is very important to understand. So if someone asks what is information, information is processed data. So the next question is, why do you want to process, or why you want process data? So the answer is process data is more important or more useful than raw data. So that is why we like information or process data rather than data. So it doesn't mean that data is not good or data is bad. Yes, data is good, but information is better, right? So that is how you have to look at the information, right? So I will give you a small analogy or the example from different field. If you take something like paddy or raw rice, that is something like data. If you take something like cooked rice, it is information. So which one you obviously prefer? Cooked rice, same thing. You will prefer information or the processed data because it is more easier for you to comprehend and more useful. Okay, right. So there are some features of information. Obviously, the information is going to be more useful than data, and at the same time, information is going to be more accurate, more easy to understand, and so many other features are there, right? So understand that the difference between data and information, because our subject is basically information systems that generate information, right? So information is not the end of the story. We have another stage called knowledge. Anyway, we'll be discussing that when we are going to discuss about knowledge based systems and stuff like that later on, right? So the next we are going to discuss types of data. So we can categorize data according to different criteria. So this is one classification: quantitative data versus qualitative data. So basically quantitative data means data that can be easily quantified, like marks of a student, balance of a account, right, amount of a bill. So those are quantitative data. So when it comes to computer or information systems, it's much more easier for information systems to represent and process quantitative data. Then we have qualitative data. So those are qualities, not quantities. Things like kindness, love, whether someone is good or bad. So those things are called qualitative data. So qualitative data has a lot of challenges when it comes to information systems and computers. Why? One thing is it's more difficult to represent. Another thing is more difficult to process. So that is where we have concepts like fuzzy logic processing, artificial intelligence, and stuff like that, especially to process these qualitative data. Okay. So another classification of data is based on their type. Anyway, I am not going to discuss that because we have done it in your other subject called computer system. You know how to represent those data also in the computer. Anyway, just to mention, we have the numeric data, character data. Collectively, we can call them alphanumeric. Then image, geographic, audio or sound, video data. Right. Then characteristic of good information or valuable information. So you can see there's a big list. So those are very important. Obviously the most important characteristic is usefulness or effectiveness. So that is why we say information is more useful than data, right? So higher the usefulness, higher the value of the information. Then of course the accuracy, completeness, relevance, simplicity, timeliness, flexibility, verifiability, accessibility, security, reliability, economical, etc. So I hope you can understand these things by just maybe you are only aware of these things, or just read the description. I will just take one or two. When we say relevance, we need information which is relevant to us. If you are getting flooded with so many information which are not relevant to us, yeah, we don't like it, right? Similarly, uh, timeliness means we need the information when we need it, right? So for example, if you take something like uh, tsunami alert, we need it quickly. So no point having that information after maybe 1 hour, right? So likewise, then things like accessibility, so we should be able to access them with a lot of ease. uh, Now you can access your account balance, so your bank account balance, by going to the bank, by going to the ATM machine, or just staying at home. That is the accessibility. right? So likewise you have to think about those things. Then we are going to discuss about the value of information. So you have to consider two factors, the time factor and the cost factor. So when it comes to time factor, earlier you get the information, higher the value. So that is why people are crazy to get the information very early, and also the people are crazy to give information very early also, right? So when you hear that the A-level results are out, everyone is going after to get their information for their results. So that is the time factor, right? It may not be true for all the information, but in general that nature is there. Then the value factor or the cost factor. So if the information is higher in cost than its value, people are not going to access it, right? So higher the cost, lesser people are interested. So therefore we want to make sure that first it has a high value, then the cost is low, right? So that is cost factor, right? So what are the usages of information? So there are a lot of usages. These are just some categories, right? Or typical usages: decision making, policy making, predictions, planning, etc. Okay, so that's self-explanatory. Right, now we have fair understanding about data and information. Right, now we are moving to the system part, because our topic is introduction to information systems. So after learning or understanding stuff related to information, now we are moving to understand stuff related to systems. Right, so again you have to be very precise, very serious. What is mean by system? Right, so system is a set of components that communicate and collaborate to achieve a common objective. So these are very important terms. Set of components communicate and collaborate to achieve a common objective, right? So that is called a system, right? So you might think, okay, this is nothing, this is something very obvious. Yes, this is obvious, but if you are a software engineer, if you are an IT professional, you will be working with systems. If you are a software engineer, you are developing software or information systems. If you are a network administrator, you are taking care of systems, right? So therefore you have to be very very serious about what is mean by system, right? Okay, so there are some examples given. Human body itself is a system, right? So school, maybe power plant, maybe a vehicle, all those are systems. You will, if you think about those things, you will see that there are some subcomponents, they are communicating and collaborating to achieve a common objective, right? So now let's look at what are the components of a system. So we have, so every system has these four components: the input, the process component, and the output. So that those three are very self-explanatory, so I'm not going to explain that. But the fourth one is also very important, that is feedback. So now we have to think about why feedbacks are important for a system. Actually you can have a system without feedback, but that system is not going to survive for long, or that system is going to be sort of a outdated dead system after sometimes if feedback is not there, right? So why we need feedback is, there are two reasons. One thing, we can by having feedback, if there are any issues in processing, we can find out and fix. If there are any issues in input, or if you want to improve the input process, input, we can use the feedback. So basically feedback will improve the process as well as find issues in the input. So therefore feedback will make sure that your systems are getting better and better every day. Okay, so now let's move on to the system environment. So the system, you can look at it as a something which is inside the boundary, so we call it system, and some things which are outside the boundary we call surrounding, right? So that is self-explanatory. Then we can subdivide systems into different categories. Right, those classifications you have to go through, because most of those classifications are just straightforward. Natural versus man-made. There are some systems which are made by nature, like forest or water system, natural water system. There are some man-made systems like vehicle, information system, etc. Then we have living system versus physical systems. So for example, human being is a living system, whereas a vehicle is a physical system. The third classification is more important for us, that is open system versus closed system. Basically, open system is a system where the input might come from outside, output might goes to the outside. So that is called open system. Closed systems are the systems where input and output is also within the systems. So if you think about the practicality, most of the practical systems are open systems, because closed systems are basically useless unless you are just keeping it closed for some experimental purpose or whatever, right? So therefore, in reality, the most of the practical systems are open systems. So obviously information systems are open systems. Okay. Then there are some other classifications like stable versus dynamic. Stable means basically once we build the system, we don't have to change much. Dynamic systems are systems that we want to keep on changing. So very good example for dynamic system is a information system. Most of the time, once we build the information system, we want to keep changing due to demand from highly dynamic business environment. But if you take something like power plant, once we build it, we don't have to change it much. So those are stable systems. So the final classification is also very important, adaptive versus non-adaptive. So first I will take non-adaptive system. A non-adaptive system means system which do not change itself, or which system which do not adapt to the environment. So that is called non-adaptive system. Adaptive system is a system that change to the environment. Right? So what we have, or what most successful systems are adaptive systems. So that is why a lot of people like smartphones. So smartphones are highly adaptive systems. It adapt to your light situation, right? So brightness. It will adapt to the orientation, right? It will adapt with some sensors whether when the phone is near your ear, it will off the screen, right? So it adapt. So, so likewise, now more and more adaptive systems are appearing with the advancement of lot of sensors, etc. Right? So those are basically IT systems. Right. So now we are moving to the measurement of success of information systems. So basically success of systems. So there are two things we can do. So the big picture is basically if a system is productive, people will call it successful system. If the system is not productive, it is not a successful system. So productivity we can have categorized into, or we can, there are some two subcategories, effectiveness and efficiency. So effective means it does the right thing, right? It does the right thing, or it do the right things. So that is called effective system. Efficient system means doing the things right. If the things are doing in the best possible way, that means it is very efficient. So basically, first we need our systems to be effective. Next, we like to have it efficient as well, right? So that is, then we say it's a very productive system. Right. So now we are moving to the system variables and system parameters. Basically, system variables are things that we can control, or the things that the decision makers have the control. So those are called system variables. System parameters are the things that the decision makers have no control. I will just give an example. If you are building power plant, uh, the decision makers can decide where to build the power plant. So that is a variable, right? So what kind of power plant, with a high uh, coal power plant or uh, hydropower plant. So those are variables. Parameters mean things that the decision makers have no control. For example, rain. Though you build a hydropower plant, you don't have control over the rain, or maybe price of the coal, right? So those are parameters, right? Let's move on to the information systems. Now we have done with systems, done with informations. Now we are moving to the information systems. So the basic block diagram is the same, only thing is now it's data flows, basically conceptual things are flowing, because normal system might have physical things also, especially in this way, but now it's more conceptual flow. Again we have the input, processing, output and feedback. So I'm not going to go through that again, right? So what are the goals of information systems? So basically, what is the information system? A system that process data input information. So that is the first thing you have to remember. Information is a system that process data into information. So there are different reasons we like to have information systems in broad. It will increase the productivity, right? So having a word processor will increase the productivity, having a spreadsheet application will increase the productivity. Likewise, it will increase the profit of business organizations. We will be discussing that later. And it will increase the competitive advantage of the business organizations. It will improve the customer services. It will improve the agility. We will be discussing those things later. Okay. Right. So what is mean by quality of information system? So when it comes to quality of information system, it again depends on two factors. That is quality of data it we input. So with regardless of the quality of processing, if the data is wrong, the output is going to be wrong. So therefore, quality of data is important. So we use this term garbage in, garbage out. So if garbage is in, always garbage is out, regardless of quality of processing. So quality of input is very important. Second factor is quality of or the correctness of processing. So that means our system must be bug free, or all the business logics and everything must be in the proper way. So that is called correct processing. So if processing is correct, if the data is correct, we are going to have the high quality output, right? Now we are moving to evolution of information systems. So early days we had manual information system, but now we are talking about computer based information systems. The short term is CBIS. So I am not going to explain all these concepts because these are self-explanatory. Manual information systems means basically information systems that we use manual, paper, pencils, files, etc. All the processing is done by humans, right? So there are some features and there are a lot of disadvantages, so that you have to go through that. And when it comes to computer based information systems, uh, it's basically we are using computers hardware, then we will be using some programs or softwares to do the processing. So just we have to enter data, and even we can automate part of entering data also. So there are some lot of advantages, right? So it's more accurate, it's faster processing, need less storage over the physical areas, faster data transfer because we can transfer data in electronic format, can easily backup and recover, etc. Okay, right. Now we are going to discuss about component of CBIS. So this is very popular question in your exam paper also. What are the component of CBIS? Basically the components are hardware, software, database, network, people, sometimes we call it liveware, policies and procedures. Remember, in computer system we just subdivided into hardware, software and liveware. So basically hardware, software and liveware is there, but we have extracted database and network as separate concept because this information system, not just a computer, right? Because the database is very important part, we have separated it out from the software, though database is also a software, right? And also we have the network and policies and procedure. So let's go one by one. Hardware, I'm not going to explain, you know what is hardware. Software, uh, you know what is mean by software also, right? So there are different types of software like system software, application software. Anyway, we have discussed those things in computer system. Then the database is where you store your data, the network where you interconnect your computers or the part of your information systems. Then the users, we call them liveware. So the final topic component of CBIS is policies and procedures. So that is also very important. So if you have proper policies and procedures only, the system is going to be used in proper context. Otherwise, there will be a lot of malpractices, corruptions, right? Issues, so many things will be there. Therefore, this component is as important as all the other components. So remember that policies and procedures are also critical part of computer-based information systems, right? Right. So life cycle we have already discussed, right? So some steps in data processing, uh, right? So remember we have the data creation. So first we have to gather the data. Sometimes it will be automated, sometimes it will be manual. Information systems will validate the entered data so that the garbage in garbage out phenomena is not there. Sometimes it will process and store, sometimes it will store and process, so vice versa, right? So there will be some data storage, processing, and of course the output of the data. So I'm not going to explain these things because these are self-explanatory, and go through different type of validations as well, right? And another important topic is the different type of data processing. So we have two main processing approaches: batch processing and online processing. So batch processing means process data batch wise. That means every month, every week, or maybe at the end of each day we process. So there are some typical usages for batch processing. But there is another type called online processing, where you can subdivide that into two again: online real-time processing and online delayed processing. Online real-time processing means you gather data online and instantaneously at the same time you process it. So there are some situations like banking systems, reservation systems, you want it to be online real time, right? Then there are situations you capture data online but you might process it with little bit delay. Things like inquiry processing systems, etc. We can call them online. Though we gather online, we might process it with some delay, right? Then there are different data output process as well as storage, etc. So those are self-explanatory. So the first topic is fairly simple topic, right? Only thing is you have to understand the basics so that you can understand the rest of the topic. And again, idea is get a very good pass for this subject. Therefore, don't take these things lightly. So you get a very good pass. Okay. Thank you.